Did you hear the joke about the proton and the neutron walking down the street?
No, what is it?
A proton and a neutron are walking down the street. The proton says, "Stop, I dropped an electron. Help me look for it." The neutron says, "Are you sure?" The proton says, "I'm positive."
Fyodor the science dork. Fyodor the science dork. Dork, 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 dork. Fyodor the science dork.
Bonding is cool.
Fyodor the science dork.
Covalent bonds share electrons.
Dork, 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 dork. Fyodor the science dork. Dork, dork, dork.
Chlorine has 7 valence electrons.
Dork, 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 dork. Fyodor the science dork.
Did you ever wonder why we have so many different kinds of objects? I mean, we have clocks, we have televisions, we have fish, we even have cats. And floors. And they're made out of so many different materials, like drywall and fabric and plastic and wood, which is used to make the floor. The reason why all of these materials are so different is because they are made out of different elements. The elements are the different types of atoms. An example of an element you might know is copper, which pennies used to be made out of. So pennies are instead made out of another element, zinc. You can determine what element you have based on the number of protons it has. For instance, zinc has 30 protons. There are a total of 118 different elements. But if there are only 118 different elements, then how come there are so many more different types of materials? This is because elements can chemically combine in order to form compounds. The way elements will combine to form compounds is determined based on what kind of element it is. There are 2 different kinds of elements, nonmetals and metals. Metals, like zinc, are usually good conductors of heat and electricity, and are ductile and malleable, meaning that they can bend and stretch. Oh, hi again. So, nonmetals, such as carbon, which is used to make the tip of your pencil, are usually brittle, bad conductors of heat and electricity, and are usually not very ductile or malleable. When nonmetals bond with nonmetals, they form covalent bonds. When metals bond with nonmetals, they form ionic bonds, and when metals bond with metals, they form metallic bonds. So you're probably wondering, why do elements even bond in the first place? Well, it all has to do with their valence electrons. Protons are located in the center of atoms and have a positive charge. Electrons move around the center of the atoms and have a negative charge. The valence electrons. Simply the electrons that are farthest from the center in the outermost layer. So, the valence electrons always want to follow the octet rule, which basically states that most elements want 8 valence electrons in their outermost shell. So, because of this, atoms will either share, take valence electrons from other atoms in order to follow the octet rule. In a covalent bond, the atoms will share the valence electrons. In an ionic bond, one atom takes valence electrons from another atom, and in a metallic bond, valence electrons. They're free to move about the alloy.
Hello there, we have a bottle of science. If you can guess one question, you get this bottle of science. According to the octet rule, how many valence electrons are needed for a complete outer shell? Let's see what our guests say.
Over 9,000!
44.
8?
Correct! You win a bottle of science. In this bottle, we have CO2. CO2 is made of carbon and 2 oxygen, which makes it a covalent bond. Here's your prize, little lady.
Hey Dad, what's a covalent bond? Ask your mother.
A covalent bond is a chemical bond that involves the sharing of electron pairs between atoms The atoms generally share these electrons in order to follow the octet rule, which states atoms will do anything to have 8 electrons in their outer shell.
Thanks, Mom.
Yeah. I'm so smart, Gold. Now finish your bread.
Hello, kids. It is I, here to present you with a new invention. I call it sodium. See what happens when I put this new flavor thing into this common dinner. Shake, shake. Wow! Who knew it would explode like that? Oh wait, I forgot. Sodium is very reactive with air and water. So kids, remember, when you're using sodium, never put it in contact with air or water. Which basically means don't put it in contact, don't take it out at all, basically. 2, if you want to be safe, mix sodium with its favorite thing, chlorine, which makes salt. And last but not least, for those adventurous types out there, use sodium because it may not look like much, but it packs a punch. Thank you.
Hi, so for this nifty home experiment, you need some steel wool, some hydrogen peroxide, some salt, and then some vinegar. Also bring paper towels, just in case. Steel wool is a metal alloy, which we're going to put in here, and we're going to spray some vinegar on it. And then we're going to get some paper towels. And try it off, just make sure that there's no vinegar left on it. And we're going to put it back in here. Spray some hydrogen peroxide on it. Put that down. Put some salt on it. And then spray some more hydrogen peroxide on it. As you can see, it's starting to change color, and that is rust forming. Here's how the experiment worked. When we put vinegar on our steel wool, it cleaned off any chemicals that may have prevented the rust from forming on the steel wool. When I put salt and hydrogen peroxide on the steel wool, the salt was dissolved by the hydrogen peroxide, and the oxygen from the hydrogen peroxide bonded ionically with the iron in the steel wool to form iron oxide, more commonly known as rust. The oxygen stole
Valence electrons
from the iron so it could fulfill the octet rule. This gave the iron a positive charge, the oxygen a negative charge, and caused them to form an ionic bond because opposite charges attract.
Hello. Black Mesa's new invention is known as brass. This trumpet here is mostly made of brass, my new invention. It was made when I was testing elements, zinc and copper. We made this brass. Brass is the ultimate alloy, has the optimum corrosion resistance, a beautiful conductor of electricity. Together with brass's 1-2 combo of corrosion resistance and electricity, we can help drive aperture science out of business. Join me now. Buy brass for the easy price of $99.99 and 15 easy payments of $59.99. Support Black Mesa today. Thank you.
When metallic elements bond together, they bond by a sea of electrons. So imagine a cup filled to the brim with marbles. Those are the atoms, so there's space in between those atoms. And if you fill the cup with water, then they will fill the space between the marbles. Those are the electrons. They move freely, which is why metals have properties such as ductility and malleability.
Da-da-da-da-da-da-da-da-da.
Story time!
Once upon a time, there was an alkali metal. His name was sodium. Sodium and his group are shiny and have low melting points. Sodium and the rest of the alkali metals reacts to other elements by losing one electron, which gives them a positive charge. One day, Sodium wanted to make some friends, so he went to visit the nitrogen family. Sodium found a friend there. One of the shinier elements in the nitrogen family was bismuth. Sodium realized that bismuth gained one electron in bonding, which gave it a negative charge. A perfect match. They instantly bonded. And lived happily ever after. What? Wait, have you guys been drawing the whole time?
Comes to say, surveillance everywhere. Trying to get 8 electrons in their everything. It's all giving and taking. Oh, she's trying to review, but the opposite rule she's going for. It's your plan for you and me. Taking my negativity, bouncing out. It's hard to follow, but giving and taking. All this is another